Solve one problem on static force analysis of 4-bar mechanism by using superposition method.
Let us first complete the diagram as per given data. Fixed link AD 800 mm. Now to draw the diagram, we will consider some suitable scale. 1 cm is equal to 25 mm. So 800 divided by 25, that is 32 centimeter. So these 2 points A to D we have to consider as a fixed length, and it is 32 centimeter. Now angle DAB is 60 degree. So here length DA is known. Now from this line we will take here this angle 60 degree, and then length of the link AB 300 mm. So as per scale, 300 divided by 25, 12 centimeter. So we will take this distance 12 centimeter, and this link AB is getting completed. Now link BC and link CD is also given, but the exact location of this point C is not known. So link BC 700 divided by 25, which is equal to 28 centimeter. So this point B is known. So from this point B we will take here 28 centimeter distance in compass, and we will mark here one arc. In the same way for this CD, 400 divided by 25, that is 16 centimeter. Then this point D we will take as a center, and we will mark one arc, and this point of intersection is the point C. So we will join these 2 points. So this CD as well as BC is getting completed. Now it is given that on this link BC there is torque T3 applied in clockwise direction. Magnitude is also given 30 Newton meter. And on this link CD there is torque T4 that is applied in anti-clockwise direction, and magnitude is also given 20 Newton meter. Now because of this applied torque, this mechanism tries to displace from its original position. So to bring the system or this mechanism in equilibrium, we have to apply the torque. So question is that how much torque is to be applied on link AB. So question is how much torque T2 is to be applied on link AB. So here we have to find out the magnitude as well as direction for this torque T2. We are going to solve this question by using superposition method, because at a time there are 2 torques that are applied on these 2 links. So we are going to split this question into 2 subgroups. In the first subgroup we are going to consider this torque T3 only, and in the second subgroup we are going to consider this torque T4 only, and then for the final answer we are going to calculate the net resultant torque. So we will first consider this torque T3 only on this link BC. We will give numbers to these links. For the fixed link AD, link number 1, then for AB it is link number 2, BC link number 3, and CD link number 4. Now what is the first step? So first step is to identify the types of members. So we will take this link AB. So if we observe this link, then there are 2 forces, that is through this point A there is force F of 1 to 2. So we will mention here this force F of 1 to 2. Then second force through this point B, F of 3 to 2. Then torque T2 is to be applied for the equilibrium of the mechanism. So there is one torque, that is torque T2. So this link AB we will consider as 2 force and 1 torque member. 2 force and 1 torque. Now we will move to the next link, link BC. So we are going to consider torque T3. So there is force through this point B, that is F of 2 to 3. Then through this point C there is force applied F of 4 to 3. And there is torque T3 that we are going to consider. So there is torque T3. So this member is also we will consider as 2 force and 1 torque member. Now we will move to the next link, that is link CD. Now if we observe through this point C, there is force applied F of 3 to 4. Then through this point D, there is force applied F of 1 to 4. Now for this subgroup, we are not going to consider this torque T force. So this member we will consider as only 2 force member. Then for link AD, through this point D, F of 4 to 1, that is force is applied. And then through this point A, F of 2 to 1. But this is the fixed link, so we are not going to consider this link in the free body diagram. So we will consider this as a 2 force member. With reference to this diagram, we will draw the free body diagram. We have to transfer all these links. So for this first link AB, we have to take the same length and we have to draw the line parallel to this. So here is the link A to B. Then we will move to the next, that is link BC. So we have to take this line parallel to this link BC and this is the line. So we have to show torque T3, that is in clockwise direction as mentioned in the question. Now for this link CD also we have to take the same length, that is 16 cm, and we have to transfer this as it is. Now we know that this AB is 2 force 1 torque member, BC 2 force 1 torque member, but this CD is 2 force member. So for the 2 force member, line of action of forces is along that link. So we will show here line of action of force. So I will show in the form of dash. Now if we observe this link CD through this point B, F of 3 to 4. So through this point C, F of 3 to 4. So this is the line of action of force F of 3 to 4 through this point C. Now through the point D, there is force F of 1 to 4. So this is the F of 1 to 4 through this point D. Now we will move to the next member, that is 2 force 1 torque member, that is BC. Now we know the line passing through point C, that is the line of action of force F of 3 to 4. So we have to show here the same line that is passing through this point C. So I will show here, we have to take the line parallel to this. Now which is the force? So if we observe this link BC, then through this point C, F of 4 to 3. So this is the line of action of force F of 4 to 3. Now for the 2 force and 1 torque member, the forces passing through the end points are parallel to each other. So we have to show here the same line of action of force. So I will draw line parallel to this. Now which force is there? So if we observe this point B for this link BC, then through this point B, F of 2 to 3. So this is the line of action of force F of 2 to 3. Now we don't know the direction of the forces, but if we observe, here is T3, that is the torque applied in clockwise direction. So we have to show the forces that forms a couple that should be in anti-clockwise direction. So we will show here this direction of force F of 2 to 3 in this way, and these two forces are opposite in direction. So F of 4 to 3 in this way. Now if we observe, these forces are in anti-clockwise direction while T3 is in clockwise direction. Now here F of 4 to 3 and F of 3 to 4 are in opposite direction. So I will show here the direction of F of 3 to 4. So these forces are equal in magnitude but opposite in direction. So I will show here. And also these two forces F of 3 to 4 and F of 1 to 4 are in opposite direction. So we have to show here the direction opposite to this. Now we will move next. So this is the line of action that is passing through B. Now in the same way, here is the same point B. So I will draw here line parallel to this. And now this link AB is two force and one torque member. So we have to draw here parallel line. So for the two force and one torque member, these line of action of force are parallel to each other. Now this torque T2 is there, but we don't know its a direction as well as magnitude. But now we know the direction of force F of 2 to 3. Now on this link AB, if we observe at point B, which force is there? F of 3 to 2. F of 3 to 2. For at this point A, force is F of 1 to 2. Now this F of 2 to 3 and F of 3 to 2 are equal in magnitude but opposite in direction. So I will show here the direction opposite to this. And here these two forces are in opposite direction. So I will show here this is the direction of the force F of 1 to 2. Now if we observe, these two forces form a couple and that is in clockwise direction, because this force will move in this direction and this force will move in this direction. So there should be torque and that will be in anti-clockwise direction. So we have to show here the torque which is in anti-clockwise direction. So this is the direction of the torque. Now we have to find out the magnitude of the torque. So how to find out the magnitude? So if we observe for this T3, we know what is the magnitude. It is 30 Newton meter. So we have to measure first what is the height in between these two lines. So how to measure this height? Height, that means we have to measure the perpendicular distance. So with the help of this protractor, these two edges are perpendicular to each other. So we have to align one edge with this one line and then we will draw here one perpendicular line. So we have to extend this. The value of h, that is the length of h, is equal to 27 centimeter. But as per the scale, 1 centimeter is equal to 25 millimeter. We have to multiply this with 25. So 27 multiplied by 25 is equal to 675 millimeter, and we will convert it into meter, that is 0.675 meter. Now if we observe this diagram, this torque T3 is equal to, we can take here any one force, that is F of 2 to 3 multiplied by this perpendicular distance h. Now this F of 2 to 3 is unknown, but this T3 is known, 30 Newton meter. So we will take here 30 is equal to F of 2 to 3 into height h, we have to take in meter because here torque is in Newton meter. So if we divide this 30 with this 0.675, then we will get this force F of 2 to 3 is equal to 44.4 Newton. Now this F of 3 to 2 is 44.4 Newton. Now this magnitude of this torque is unknown. So how to find out this? So again, these are the parallel forces. So we have to find out what is the perpendicular distance in between them. So we have to use this protractor and I will align one edge and I will draw here one line. So this is the perpendicular line and this height is known as h1. So this h1 is equal to 2.5 centimeters. So as per this scale, 2.5 multiplied by 25 millimeter is 62.5 millimeter. Now we will convert it into meter, that is 0.0625 meter. Now we know that how to measure this torque. So torque is equal to this force F of 3 to 2, or we can take this F of 1 to 2, any one force we can take. So F of 3 to 2 multiplied by h1. Now we know that this f of 2 to 3 and f of 3 to 2 are equal in magnitude but opposite in direction. So we will take here this magnitude same, that is 44.4, multiplied by this height h1 0.0625, and which is equal to 2.775 Newton meter. And what is the direction? So direction is anti-clockwise, so we have to mention here. So this is the answer of the first subgroup. So we will consider here T as a first subgroup. I will consider as a to the base A. So TA. Now we will move to the second subgroup. In this subgroup we will consider torque T4 only. First step is to identify the types of member. So first we will take link AB. So for this link AB, which forces are applied? So through this point A, f of 1 to 2. Through this point B, f of 3 to 2. And there is torque T2 that we have to find out. So this is 2 force and 1 torque member. Now we will move link BC. So here this time this T3 is not considered. So there is force through this point B, f of 2 to 3. Then through this point C there is force f of 4 to 3. So this is 2 force member. Now we will move to the link CD. So for this link CD, through this point C, force transferred is f of 3 to 4. Then through this point D, force transferred f of 1 to 4. And there is torque T4 that we have to consider. So I will write here the torque T4. So this is 2 force and 1 torque member. Now we will draw free body diagram. So for this, with reference to this diagram, we have to transfer all these links. So length should be same and all the lines should be parallel to these links. So we have to transfer with the help of roller. Now if we observe link AB, 2 force 1 torque, BC 2 force member, CD 2 force 1 torque member. So this is the simplest member, that is link BC, which is 2 force member. And what is the rule for the equilibrium? That is the line of action of forces for this 2 force member is along that link. So I will draw here the line of action of force. Now which force is there? So through this point B, so we have to observe this BC. So through this point B, f of 2 to 3. So this is the line of action of f of 2 to 3. And through this point C, f of 4 to 3. F of 4 to 3. Now we don't know what is the direction of the forces, but we know it's a line of action of force. Now if we move to the link CD, then now through this point C we know what is the line of action of force. So I will draw the same line of action of force, that is the line parallel to this but passing through the point C. So this is the line of action of force. So which force is there? So through this point C, there is force transferred to CD is f of 3 to 4. Link CD is 2 force and 1 torque member. So we have to show the line of action of force passing through point D should be parallel to this f of 3 to 4. So I will show here. Now if we observe this link CD, then through this point D, f of 1 to 4 is applied. So here we have to mention this. Now for this link AB, we have to show the same line of action of force passing through the point B. So through this point B, we will take here one line parallel to this and we will draw this line. Now if we observe this link AB, then it is 2 force and 1 torque member. So here T2 torque is to be applied, but we don't know its a direction as well as magnitude. But what is the rule for this 2 force and 1 torque member? The line of action of force should be parallel to each other. So we have to show here this line of action of force. Now for this link AB, which force is passing through this point B? F of 3 to 2. And for through this point A, F of 1 to 2. So this is the line of action of force F of 1 to 2. Now in this question, magnitude as well as direction for this T4 is given. So T4 is in anti-clockwise direction. So we have to form a couple for these two forces in such a way that they should form a clockwise direction. So for this clockwise direction, we have to show the direction of F of 1 to 4 is in this upward direction, and direction for F of 3 to 4 is in the downward direction. So if we observe, it will turn into this clockwise direction, and T4 is in opposite direction. Now we will decide the direction of other forces also. Now this F of 3 to 4 and F of 4 to 3 are equal in magnitude but opposite in direction. So we will show here the opposite direction. Then F of 4 to 3 and F of 2 to 3 equal in magnitude but opposite in direction. So I will show here the direction opposite to this. Then in the same way, F of 2 to 3 and F of 3 to 2 are equal in magnitude but opposite in direction. So I have to show here the direction in the upward direction. Now this is in the upward direction, that is F of 3 to 2. So the opposite force F of 1 to 2 should be in the opposite direction, that is in the downward direction. If we observe, these two forces form a couple in the clockwise direction. So this torque T2 should be applied in anti-clockwise direction. So this is the direction. Now we don't know what is the magnitude of this applied torque T2. So this is the answer for the second subgroup. So how to find out that? So for that, this is the known magnitude as well as direction for this T4. So how to calculate this T4? So T4 is equal to this any one force, that is F of 1 to 4 or F of 3 to 4 multiplied by the perpendicular distance h. So how to find out the perpendicular distance in between these two lines? So for that we have to use this protractor whose two edges are perpendicular to each other. Now I will align one edge to this line and I will draw one line perpendicular to this. So this second line should be perpendicular to this line. So these two lines are parallel to each other. So this is the height h. The value of h is in centimeter 14.5. But as per scale, we have to refer 1 centimeter is equal to 25 millimeter. So 14.5 into 25, that is 362.5 millimeter. But this torque T4 is 20 Newton meter. That means unit is meter. So we will convert this into meter, 0.3625 meter. Now how we can solve this? So T4 is equal to F of 3 to 4 multiplied by this h. So this F of 3 to 4 is unknown. So T4, that is 20, which is equal to F of 3 to 4 into 0.3625. So F of 3 to 4 is equal to 55.17 Newton. So this force F of 3 to 4 and F of 4 to 3 are equal in magnitude but opposite in direction. So F of 4 to 3 and F of 2 to 3 are also equal in magnitude but opposite in direction. And this F of 2 to 3 and F of 3 to 2 is also equal in magnitude and opposite in direction. So we can take here F of 3 to 2 is equal to 55.17 Newton. Now we have to find out the magnitude of this T2. So again we will find out the perpendicular distance with the help of this protractor. So we will align one edge with this one line, and this is the perpendicular edge. So we will measure this height h2, and if we measure this height h2, then it is 11 centimeter. So 11 into 25 is equal to 275 millimeter. But we have to find out the torque in Newton meter. So we will convert it into meter, 0.275 meter. So T2 is equal to this f of 3 to 2, that is 55.17 multiplied by 0.275, and which is equal to 15.17 Newton meter, and direction is anti-clockwise. Now this is the answer for the subgroup, that is second subgroup. So we will say this will be the value of TB, that is torque for the second subgroup. So what was the value for TA, that is the torque for first subgroup, and that is 2.775, and the direction is also anti-clockwise. So for the anti-clockwise direction, if we consider the plus sign, then here resultant torque is equal to plus 2.775 plus 15.17, which is equal to 17.945 Newton meter. And what is the direction of the resultant torque? So final, for this whole mechanism, direction for this T2 is in anti-clockwise direction, and magnitude is 17.945 Newton meter.